Hello everyone. Today I want to explain branch prediction with some basic examples. First of all, I need to create a vector with 1 million elements, and I want to calculate each elements of vector is greater than 128. First of all, I need to include vector for using std vector. And I create a vector. Okay, I create integer vector. And also I need to fill this vector with random numbers 0 to up to 256. Why my compiler can't see Win32? I need to include iOS string also for calculating time for I need to print duration times console for comparing naive calculation and sorted array calculation. I need to calculate sum of the array elements if the elements is greater than 128. And we will see the performance difference between normal calculation, naive calculation, and sorted array calculation. For this reason, I need to give address of the vector because I changed elements of the vector, and I also need to resize before filling this vector with random numbers, and also constant expression at size t size. I need to define the vector size before starting. In this example, I want to use 1 million elements for vector, and I resize my vector with using these constant expressions. Yes, we have some space for 1 million elements. Also, we add elements inside of the vector. Index is less than size. Increase the index. And I want to define each element randomly. Vector index is equal to rand mod 256. Okay, let's start to calculate vector's element is greater than 128 and calculate to this operations time, and I want to include std chrono for time calculations because it's high frequency clock, and I want to create two functions for this. First of all, I calculate naive implementation. For this reason, my return value of this function is win64. For that, win64t, yes, naive implementation. And also I need to give function parameters of this vector, and I start to calculate win64 t naive calculations and I initialize it 0. Also, I need to start chrono auto start time std chrono high resolution clock. Now it starts to current time, and I start to implement for loop. I want to add some busy calculations for seeing much good for calculations. Outer index. If outer index is lower than 1000, let's start with 1000. Increase outer index. Oh, I write some spelling mistake. Okay. And inner loop is calculating the elements. I define inner index, and also inner index is lower than const expression, it meaning size for this program. I increase inner index. Okay, at this time I need to check branch if the vector elements is lower than 128. Inner index is lower than 128. Make some calculations. Cumulatively summed using vector inner index. Yes, now we need to calculate end time of this function with using current time, and also we need to print this end duration. Duration seconds is std chrono duration test. std chrono seconds dot count. Just give me a second for duration test implementation. Yes, like this. And time minus start time. Count, yes. We have now duration in seconds, and also I want to calculate duration in milliseconds. Nanoseconds is not important for this example. And also we need to print these durations. Naive implementation for branch prediction. Yes, and we can now print iteration in seconds. And also, sorry. Yes, I add the units of the durations. Yes, now we can calculate our vectors. The elements is greater than 126, not 6, 8. At this point. Yes, naive implementation vector. I forget field vector coding. Yes. Where is my, yeah. Also I forget the type of the vector. Yes. We are ready for naive implementation calculations. And before starting this code, I also want to implement sorted array version, naive sorted implementation. I just add one function for this, and I use algorithm library for C++, SPP sort. It's basic sort function, and it needs to be set vector begin and vector end. Yes, now our vector is sorted, and I make same calculation for sorted array, sorted random array, and just normal random array. And I want to see the performance difference between these two functions. Not array, sorry, it's vector. Okay, now we are ready for compile and runtime. Yes. I create a makefile before starting the video. It don't use any compiler optimization and compiler with C++ 17. And if I run this command on terminal, this code start to building, and after the build operation, executable files will be run, and we will see the results of each functions. Oh, sorry, I forgot the return values of each functions. Yes, I think now we are ready. Yes, I forgot also some space for printing duration. Just give me a second. Yes, without any compiler optimization, the naive implementation take 6 milliseconds, and sorted vector implementation take 180 milliseconds. But if I increase the outer indexes of both loops, the results will be changed. Just give me a second. So I think I made a mistakes or inside the function. Yes, greater than, not less than. I include this. Yes, it's correct. It's correct. Vector. Not 32, 64. Some results for maybe sorted. Also, I want to add some if statement. Result is the same. Result not same. Okay, I think I make a mistake inside the calculation parts. The vector inner index, yeah, inner index is less than. Okay, okay. Okay, I changed for loop. Yes, after the corrected calculation, we need to wait the results. Sort array results is need to much faster than normal naive implementation, because if we sort the array, the compiler can now each element is greater than 128 or less than 128. It's called for a CPU or predict a branch. If we sort the array looks like this. And the CPU start to predict the results like this. In first iteration, CPU seems the result is false. And CPU's second iteration, the result is also false. As CPU's third iteration is also false, and the CPU's fourth iteration is also be false. After this time, CPU starts to calculate each element with 4 rows. After the middle of the calculation, it's start to be true. At this time, CPU starts to warm up again. And after the 4th iteration, CPU start to predict again. For this reason, the results of sorted array implementation is 4 times faster than normal naive implementation. Thanks for watching.